Let's take a look at polygon congruence. In two congruent polygons, all parts of one polygon are congruent to the corresponding or matching parts of another polygon. Corresponding parts include the corresponding angles and the corresponding sides. So in the model, we can only say that these two polygons are congruent if we know all of the corresponding sides and all the corresponding angles are congruent. So for corresponding angles, what's nice about this diagram is they color-coded everything so you can kind of easily see which pieces are congruent. Yours obviously won't be color-coded when you're working on your test or in your homework. However, you're looking for the way things are marked. So if you're looking at the angles, angle A, you'll notice has two little arcs on it, and so does H. So angle A and angle H are congruent to one another. Angle B has one arc, and J also has that same one arc. So angle B and J are congruent to one another. And then finally for angle C, it has three little pink marks, and so does K. So that means C and K are congruent. So we know all of the corresponding angles are congruent. For the sides, the corresponding sides are the ones that have the same mark on it. So AB has one little hash mark, and so does HJ. So segment AB is congruent to segment HJ. BC has two little marks on it, and so does JK. So segment BC is congruent to segment JK. And finally, segment AC has three pink marks on it, and so does segment HK. So segment AC is congruent to segment HK. Once you establish that the two polygons are congruent, then you can make a congruent statement. When you make a congruent statement, there isn't one right way to do it, but there are definitely incorrect ways. So when you name your first polygon, you need to make sure that you name the second polygon in the same order so that the corresponding angles are written in the same order. So for this particular congruent statement, it says triangle ABC is congruent to triangle HJK. So since H and A are congruent, they're both in the first position. Since B and J are both congruent, they're in the second position, and C and K are congruent, they're in the third position. I could easily say CAB is congruent to KHJ, or I could say triangle BAC is congruent to triangle JHK. So there's not one correct way to write a congruent statement, but there are incorrect ways and correct ways. So you need to be careful when establishing your congruent statement. So definition of congruent polygons, I kind of already said it in the last slide just to re-emphasize. If two polygons are congruent, then their corresponding parts are congruent. Likewise, if the corresponding parts are congruent, then the polygons are congruent. So in this example, we are asked to find the values of x and y, and we're told that triangle ABC is congruent to triangle DFE. Really important that you pay attention to that congruent statement so that you know which angles are congruent. So if I'm looking at angle B, I can see that it's marked 99 degrees, and angle F is marked 8y minus 55. If I look at that congruent statement, B and F are in the same location, so that means that those angles are congruent to one another. So if I want to find the measure of angle, or if I want to find the value of y, I can set the measure of angle F, 8y minus 5, equal to the measure of angle B, which is 99. And then I'll just solve this by adding 5 to both sides. So that gives me 8y equals 104. And then I'll divide both sides by 8, and that will leave me with y equals 13. So now I can look to figure out how to find x. X is right here, 2y plus x. That side FE, FE is going to be congruent to side BC, which BC we know is 38.4. So I'm going to set 2y plus x equal to 38.4. And then I'm going to substitute y with 13 because we just figured out what y is. Otherwise, I would not be able to solve that. 2 times 13 is 26. And then I'm going to subtract 26 from both sides. And that's going to give me x equals 12.4. And this is only possible because I knew the two triangles were congruent. Something else that's helpful is the third angles theorem. And what it says is if you know that two angles of one triangle are congruent to two angles of another triangle, then that's going to mean those third angles also have to be congruent. So in this picture, I know angle A and angle D are congruent because they have the same mark. I know angle B and E have to be congruent because they have the same mark. So I'm going to be able to conclude that C and F must also be congruent because we know that the sum of the angles has to be 180 degrees. So if two of them are the same, then by default, the third must also be the same. All right, so we're going to use what we know about polygon congruence, and we are going to do a couple proofs to prove some triangles are congruent. So for the first one, we have a lot of given. So everything's marked in the picture. We know DE and GE are congruent. That's the sides with one mark. We know DF and GF are congruent. That's the side with two marks. We know that angle D and angle G are congruent because they both have two little marks on those angles. And we know that angle DFE is congruent to angle GFE because they have one little mark. Notice on that one we have to use all three letters to name the angle because there are a couple of different angles coming off from angle F. So we're going to start. We listed all the given for step one, so our reason is given. For step two, our goal is to prove that these two triangles are congruent. So if these two triangles are congruent, we need to know all their corresponding sides and all of their corresponding angles are congruent. And we have 2 of 3 sides, and we have 2 of 3 angles. So in the last slide, we talked about the third angles theorem, and that said if you know that 2 pairs of angles are congruent within those 2 triangles, then those third angles have to be congruent. So I'm going to use the third angles theorem to state that angle DEF has to be congruent to angle GEF. And again, that's that third angles theorem. So now we have all 3 pairs of angles are congruent, and I can add that. I can try to add that to the picture. 1, 2, 3, 1, 2, 3. So now I've got all of the angles. So the only side that I'm missing is that side EF, and EF is in both triangles. So I can say that EF is congruent to EF, and I talked about this in the last unit, how you would start to use this property a lot. This is your reflexive property, when something is equivalent to itself. But it's important to say that side because it is in both triangles, and it is the third side of both of those triangles. So now we've got that third side as well. So now we have either been told or we have proven that all 3 pairs of corresponding angles are congruent and all 3 pairs of corresponding sides are congruent. So we now know that triangle DEF is congruent to triangle GEF, because that is the definition of congruent polygons. Again, paying close attention to the way we're writing that congruent statement. D and G are congruent, and then we have E and then to F. All right, another proof. We're proving 2 triangles are congruent, so we do need to somehow show that all of the corresponding sides are congruent and all of the corresponding angles are congruent. So they did give us 2 pairs of side. We've got JK and PM. We also have JL and PL that are congruent. And then they gave us 1 angle, so angle J and angle P. So they gave us quite a bit. They gave us 3 of the 6 things that we need, essentially. All right, but they did also tell us that L is the midpoint of KM. And if L is the midpoint of KM, that means KM is cut in half. So what that would mean is that ML would be congruent to KL. So we are going to make that statement next. I forgot to write given here. So we just said ML is congruent to KL. So now I have shown that all three sides are congruent. So now I need to work on the angles. All right, so what we do have in the shape, anytime you see this kind of bow tie looking figure, you're going to have vertical angles. Remember, vertical angles are the angles opposite one another. So in this case, that would be angle JLK and angle PLM. Those angles are going to be congruent because they're vertical angles, or the vertical angles theorem. So now we have two of the three angles that are marked congruent. So if we have two of three angles, then we can conclude that the third angles, angle K and angle M, are going to be congruent because they are the third pair of angles. So now if I look at that, I've got all three pairs of corresponding sides marked congruent and all three pairs of corresponding angles also marked congruent. So we can state that triangle JLK is congruent to triangle PLM, and that is by the definition of congruent polygons. The definition of congruent polygons. And in our upcoming lessons, we're going to find a way where we can shorten this. There are going to be quicker ways to prove that two triangles are congruent. But this works for triangles or anything, any shape beyond triangles as well. You would not be able to use the third angles theorem unless it was a triangle.